Work it, make it, do it, make sense.
Hey guys, I'm Prateek Bhatnagar, and welcome to Progressive Web App Session. I work with Google, and I work in Google Cloud, G Suite team, and Google Chrome as well. So a big part of my job is also to build libraries and frameworks to help developers build progressive web apps. But what are progressive web apps? I'll give you an introduction, take you through all the APIs, take you to a lot of code on how to build these things, hoping that you'll be able to go back and build a couple of these. But in order to introduce these, a quick raise of hands, how many of you use your mail clients, maps, and all sorts of these applications in a web browser on a desktop? Awesome. And just keep your hands up if you use the same in a web browser in a mobile device. Okay, as I expected. So there are very few of us who use our mail clients or maybe our maps application and maybe our social networking applications in a web browser. So what happened there? Why did we were using these for a very, very long time in a browser on our desktop. So when we moved to mobile, why did we switch to native apps? There were a couple of reasons behind it. So for example, my mail client, even if the network's not there, it is able to show me a couple of my recent mails. My social network is able to show me my recent feed, which my friends have posted. Even if the network's not there, the UX is much better, and sometimes it does things for re-engagement. For example, sends me push notifications, which web for a very, very long time was not able to do on mobile. Surprise. So with progressive web apps, you can do all of this with your current mobile websites. So just to put it in a nutshell, progressive web apps are your websites with these 3 points. First, they are network resilient, which means does not matter if your user is on a 2G, is on a 3G, is on Wi-Fi, or even if they are offline. Your websites will still work. They will still be able to show some content which you decide what should be shown in case if there's no network. Second, response fast. With progressive web apps, you can add your websites to users' home screen and app menu as an icon, just like native apps do. So in this case, your users do not know which icons are basically native apps or which icons are progressive web apps. In which case, they expect both of them to respond equally fast. If they click your website or progressive web app, should respond really quick. Under 5 seconds, they should get really interactive. And with the help of a new API called Service Workers, you have a very fine low-level control over your cache. You can decide at runtime which assets to bring from cache, which assets to bring from network, and you can switch between these two at the very runtime. So with such fine-grained control, you can respond to your users' need in a super fast manner. Third thing, engaging. So PWAs have been proven to have better re-engagements with the help of push notifications. Using again the same service worker API, you can send push notifications to your user who are using your websites. They do not need to download your native apps in order to get your push notifications. Your websites are able to send your push notifications to your users just like your native apps do. So just a brief look, what exactly are you missing if you are making conventional websites instead of progressive web apps? Imagine you are building a game. So if your user is bored and he or she is fiddling with their phone, the chances are really low that they will go to a browser, type a URL, and expect something to pop up on their screen. They'll look into the icons that's there on their home screen or on their app menu and will probably give time to one of those products. So if you are building a conventional website, the chances of you landing on their home screen or the app menu are really low. Next, The multiple businesses like an e-commerce or a cab aggregator loses the power of notifications. You cannot tell your users that, okay, we are hosting a sale tomorrow, or your cab is about to reach your destination if you are building a conventional website. Third thing, your web is responding really, really slow. And your apps, this might be a one-off thing and maybe a little debatable, but your apps are really heavy to download in comparison to opening a web page at once. So if your user is able to open a web page and able to view it on bad networks, it's way better user experience than downloading a particular app. Fourth thing, your web presence goes on and off. So I'm pretty sure a lot of us have already witnessed this. If you are traveling in a metro, if you're traveling on an airplane, the chances are really, really high that you will lose your network. And at that point of time, if your website is a conventional website, your users will not be able to access any kind of data. Because with conventional website, you need to connect to internet and then send HTTP requests and then response will come. But with progressive web apps, you can basically have the control of your APIs as well as your assets of web page are coming from which source, either from cache or from network. Mind this is really different from your older kind of caching, maybe HTTP caching. They are very declarative upfront. Okay, this asset is supposed to be cached for X amount of time and do not come back to network if before this particular time. With the API called Service Worker, which we will discuss in a short while, you can tell the browser that, okay, if the network is present, go fetch the data from network, get me the freshest API response, get me the fresh user data. If the network is not there, go first fetch all the data that we last viewed from the cache. So in case, just for example, if I open my social network, it should be able to show me the previous feeds that my friends have posted, in case the network's not there. And if the network's there, it should always be able to fetch fresh data, fresh content from my servers. Another thing, so if you're building a conventional web experience, mind this: all your users are spending 80% of their time inside a mobile in their top 3 apps. If you're building a native app, the chances are the usage that your product should get is really, really low, because users tend to get stuck in top 3 apps itself. Whereas with websites, if you share a link and that link has another hyperlink to another website, the chances are really high that the user will just click to it and navigate to some other website, see some other content, and that content can be one of yours as well. So the barrier of downloading a native app, installing it, and then viewing it is out of the entire flow. So again, how can PWAS help you? This is very specific to the APIs that I'll be discussing into this entire presentation. The first is network resilience. The API that brings this is Service Worker API. Service workers are basically a JavaScript file that runs in a background thread of your browser. So now it has the capability to run some portion of your scripts while the user might have even closed the browser. This was not possible before Service Worker. Any piece of code that you write as your website was only executable until and unless your tab of your website was open. Now with Service Workers running in a background, you can do tons of stuff even if the user is not on your website. This is really, really taken care of in a very delicate manner, that if you are doing a very long pending task, the service worker or this background thread is killed and is only awakened on certain kind of events that we'll discuss. Engaging for users, as I told you. Now, since this thing is running in a background thread, your websites can now receive GCM push notifications even if the user is not active on your website. So earlier, what we used to do is we used to poll the particular server or tons of other technologies that used to tell us, but they were only limited till the time that I was using your website. For the desktop, this case was not as big because most of the times most of my tabs were always open. But for phones, if I just press the home screen, all the tabs, all the websites, and the browser itself is closed. So there was a dire need of something that was running in background, which Service Worker has actually brought to the table. Okay, so what are service workers? As I told you, that it's a JavaScript file which is downloaded separately that you can tell when to start downloading. It's a separate JavaScript file that is downloaded separately and put inside a background thread. Now, since this is put inside a background thread, this JavaScript has a different lifecycle of its own. This is the service worker lifecycle. The service worker lifecycle. Once you tell the browser that this is my whatever, giving the path, whatever is my service worker file, it will first download that file and try to install it. There can be multiple service worker files that is affecting your page, and hence the browser makes sure that first after downloading your file is getting installed in the background, and then it's activated. So after getting activated, your new service worker file will get the control of your particular control page. After it, if there is nothing getting executed, it will be put into idle. So from idle, service workers are basically waken up by the browser on particular events. So if you are making a network request, your service worker will be notified, hey, this is the network request going out from this website. Do you want to modify it? Do you want to do something with it? And this is particularly the chance that you decide, okay, I'll first go and check if the network calls are failing, I'll just grab it from the cache. Or let's say, hey, if the network is healthy, I'll just go to the network and grab the freshest content. Or maybe message. So a browser will also wake up your service worker script in case it receives a GCM push notification on your behalf, and tell the service worker, hey, I've received a push notification, here is the data, and decide what do you want to do. So you can create a push notification and show on a user's device. Okay. This is a very simple code that you write to download the service worker and do something with it. So in your index.html, you just write these 4 lines, check if the service worker is in Navigator. Now, progressive web apps have the word progressive for a reason. Your website, your progressive web app will continue to work as is if your browsers do not support the new APIs. So hence, all of this is protected in a very progressively enhanced manner. We'll check if the Navigator has the capability of service worker. We'll do a service navigator.serviceworker.register, and then the path of your JavaScript file. Now, this returns a promise telling that, hey, whether was this file successfully downloaded and installed or not. Also, there's an option of scope. You can now, service worker is like a proxy sitting between your browser and the network itself. So it's a pretty hefty thing. So there are few things that you need to keep in mind. You can specify a scope or the URL of around which the pages will be controlled. And also, the service workers are only available in HTTPS. Since they are a very proxy kind of sensitive things, browsers only allow service worker usage in an HTTPS or a secure environment. Whereas in the service worker file, you can just add an event listener as fetch and respond with whatever custom response you want. So this code will basically get activated on every outgoing request. So any request, any CSS, any JS, any API request that you make to your server at this point of time will be responded with just a text of hello. Let's look at a more real world use case. If in case your code executes without any error, as seen in the previous slide, there will be a service worker file shown in the applications tab in your Chrome Dev Consoles, that this particular service worker is currently running or is now activated and it's now running. You can also emulate different kind of events like a push event which is basically generated when a push notification is received, or a sync event, which is generated when you register for a background sync that we'll shortly discuss, and you get network back. Now, here is how you achieve offline first. You declare a name of the cache, you declare particular URLs to be cached, and then in the install step, as we saw that the service worker has a lifecycle, the first event in the lifecycle was install. While installing the service worker, what browser will do is open the cache. In line number 11, you'll see caches.open. It will open a cache with the predefined name and add all these URL and its responses inside the cache. Now, in order to use this response, we'll again add an event listener of fetch. And now, whatever request is coming to us, we'll do a caches.match event.request. Now, this will tell that whether or not cache has this particular request already cached. If in case the response is there, we will return the response. Now, this response is sent from the cache. In case the response is not there, in case we have not cached this particular request, it will just fall back to network as return fetch event.request. Now, this line return fetch event.request, what it does is it will just allow your request to go to network as if there was no service worker between it. So now this particular strategy is called cache first strategy. Every outgoing request, you first go and see if it's already cached. If it's not cached, let's go and fall back to a network. This is particularly good in case you are following an app shell kind of network where the user comes to your website and you cache the entire shell, a blank shell of your web page, and you only go out to network for your API request. So for all the assets, your CSS, JS, and other kind of things, you fall back to your cache, and only for your API responses, you go to your network. This is a very similar kind of approach what native apps currently do. Okay. Now that was a lot of code to handle a very small task. Now comes the helper tools. The import scripts is, you can think import script function as an equivalent of a script tag in your markup. You give a URL of a script inside the import scripts, and what it will do is, it will fetch that script, it will execute that script, and then execute the rest of the code that you have. What next line toolbox.router.get is, toolbox is basically a helper library. What it does is it gives you express-like caching, express-like routing, and you can write which URL should use which strategy. So namely, there are 5 main strategies. First is cache first, which is look for this URL into the cache first and then go to the network if it's not there. Second is network first. Look for this URL first at the network. If the network is not available, then go and look into the cache. Third is cache only. Do not go to network. Just always return from cache. Fourth is network only. Please always get the data from network. If not, just fail. Do not go to cache and look at it. And fifth is a very interesting strategy that's called fastest. You send 2 requests, one to cache and one to network, and whichever resolves first, your data will be first sent to the control page via that particular source. Now, you send 1 request to cache and 1 request to the network, and whichever first comes, your page will get that response. So here, what I'm trying to do is the home URL, it's first given through cache first. That always look for index.html or my root HTML into the cache. If it's not available, then go to network. Whereas I can also do some other kind of properties to it. So I can give a cache name to where look into it. I can give the maximum number of entries and the max age for this particular cache. So what it does is, just suppose if you are into an e-commerce and you have to store last 5 searches of your user, your entire progressive web app or the website is now served from cache, and now even your last 5 searches that your user did is now into the cache. You can, with max entries as a number, you can also control this thing. So for example, suppose I search for shirts, t-shirts, pants, trousers, jackets, sweaters. So my last 5 searches will always be in your cache. So even now, if I'm traveling, even if I'm in an offline mode, on an airplane mode, I can look the last 5 searches that your particular website returned to me. So here's a use case of what else other than just the assets can you cache. As we discussed, you can cache some of your last used searches. You can also cache your last recent mails, just like your native apps do. You can also cache your last incoming feed, or maybe an entire game. So think of it like this. Now, with a low-level API like a service worker, you have the entire control written in JavaScript, and it's at your disposal to decide what to do at what point of time. So some of these use cases are what are easily achievable using a service worker cache. Okay, now comes Manifest. Service worker do the behind the scene kind of stuff. It does what to respond and when to respond, from where to respond. But in order to add your website to users' home screen, it needs a lot of settings, like how it should look, what icon should it have, what particular name should it appear on the user's home screen. So a small link tag in your index.html as link.rel manifest slash href as the URL of the manifest itself can tell the browser, okay, hey, here's the JSON that describes most of my progressive web app, or the information about the progressive web app. Go fetch this, and when the user requests it to add to home screen, please take the settings from this one. So a few to name are the name itself. The name will appear on the home screen. The short name, in case there's a scenario where there's not enough room on the screen of the user's phone. A description, a theme color. Theme color is basically the top bar in case of Android, where battery icon, Wi-Fi icon, and other icon appear. So whenever your progressive web app will be open, the particular bar will have a different color now. By default, it's always a translucent black, but you can define whatever color suits the branding of your progressive web app. Next is the background color. So whenever the user now taps on your icon, the browser itself will show a splash screen. The splash screen will have the name of your product, the icon of your product, and this background color in the backdrop. So while your page loads, the user will be shown a particular splash screen instead of a white blank screen that the user was seeing in case of a regular browser. Okay, so Manifest is, in case you want to follow what are the deep capabilities of this particular manifest, follow this URL. This is the spec of the W3C, and there are new capabilities that are being added, so which you can follow there. And in case you want to generate one, these are the 2 URLs. You can go to the URLs, just put in some data, give them the upload your icons, and they will generate the full entire manifest for you. Now this is particularly what your progressive web app looks like. First is the normal website open in a browser with the URL bar and everything. If the browser sees that, okay, hey, this is a progressive web app, it will show a banner to the user. Hey, do you want to add this to home screen? If the user presses add to home screen, an icon and a name of your product will be on the user's home screen. So now at this point of time, the user do not have to go back to the browser and retype the URL or even type a few letters of it. He can directly tap this, and an experience that is seen on the last will be presented to him. Please observe there's no URL bar. There is no other browser UI itself. It's all like a native app, open full screen, but is your website. And these are the 2 properties that help you do this. The first property is a display. So you can choose if the user clicks the home screen, what will be the UI shown that will be shown to the user. It can be either full screen, it can be either standalone. So full screen, even the battery bar and the top bar will disappear. This is mostly used in cases of games. So there's no UI of phone altogether. Whereas standalone is what we saw. This is a particular, the one on the last is the standalone. It will still have the phone stop bar, but no UI of the browser itself, or minimal UI or the browser as default, as we see websites today. Next is the orientation. You can decide whether, when tapped on the icon, whether your PWA will open in a portrait mode primarily or on a landscape mode. So in case you are developing a game, you might want to choose a landscape mode instead. And this is basically how the adding to home screen looks like. You can trigger this banner, and this banner will be shown to the user, which again the user can choose to opt out of or can choose to keep it on the home screen. Okay, but the entire thing of home screen story has no API to it. There is no piece of code that you can run in your JavaScript and show that particular banner to the user. So how do we basically do it? So browser has a few checks before it shows the banner itself. There are few heuristics, like your website should have a valid service worker running, an active service worker running to it in the background. Next, there should be a manifest added to your index.html and every HTML that the website is being added to a home screen from. And third thing is user should have spent some amount of time on your website. If these three conditions match, the browser itself shows the add to home screen banner. Now the reason behind one of the main reasons behind this is, imagine there is if you are jumping links from links and landing on different websites, and every website starts showing add to home screen first as soon as you land on that particular website, it would be really, really obtrusive for the user. So in this case, the only way to do it is your browser gets satisfied with these three conditions and it will show that particular banner. But there might be a condition where it might not make sense for you. For example, let's just take an example of a game. There's a loading screen at the beginning, but you have a valid service worker and you have a JSON manifest. In that case, immediately the browser will show the add to home screen banner, but your user itself has not seen your product. He has not seen your game, he has not played any game, all he has seen is a loading splash screen. What to do in that kind of case? So in this case, before showing the banner itself, browser fires an event on the window object. The event name is before install prompt. So here, just as we have did it for ages, you can do a event.prevent default. This will stop the browser from showing that banner. You can store this particular event reference into some variable, and whenever you feel that this might be a right time to show the banner, where, for example, user has played 1 or 2 levels, or played your game for some levels or time, or has shopped from your e-commerce, and you think that this might be a very good time to show that particular banner, you can just call window dot or whatever variable you stored that event into it dot prompt. This code will just show the banner now, and you can get a promise by your event dot user choice, and it will resolve in case the user has opted to add to home screen, and it will get rejected if the user has pressed the little cross icon and has rejected your request to add to home screen. Okay, now to push notifications. Now this is one of the features that web has really, really waited long for. Now web can send push notifications just like your native apps do. This is one of the example experiences how web sends push notification. Now before sending the push notification, this thing is guarded by a permission model. Now, the same the same kind of thinking gets applied even here. So if you browse to 5 websites and they all start sending push notifications to you, I am pretty sure a lot of us will be upset. Hence, before sending the push notification, every website needs to get your permission. Only and only if you say allow, the websites will be able to send the push notifications to you. And now the push notifications are themselves powered by its service worker. As I told, before service workers, there was no one to receive your GCM push notifications if your user has closed your tab or your website. Now, since the service worker is living in a background thread, even if your tab is closed, even if your browser is closed in case of mobile, there is a script of your service worker that will be able to receive the push notification and will have the logic to what to do with it. A very simple example is in your service worker.js, just do at this or self.add event listener. The event name is push. You will get the event, and event.payload will have all the payload that GCM is sending to you. But regardless of it, you can create a title, you can create an option which will have body, your icon to show on the left, your badge to show just underneath the icon, and the action buttons that you want to show with the push notifications. Now, the icon, the badge, and the actions, all of these are optional. You can choose whatever fits your use case at that point of time. And a small code event.wait until self.registration.show notification will generate a notification just like this for your users. Okay. Now there's a small code here that is event.wait until. Why exactly this? So if the browser allows a script to live in background, there are tons of things that a developer can do but a user might not want. Hog on to the user's device resources, keep on executing some code while user might not even know it. So in order to prevent all of these, browser kills your service worker as soon as it finds out that your service worker itself is not doing anything, is not executing any code. So if we don't do event.wait until, your entire function would have executed, and so the browser would have thought, hey, the service worker looks idle, let's just kill it. So in order to avoid this, we do service worker.wait until this function takes a promise, and self.registration.show notification returns a promise. So unless your notification is constructed and shown on the user's device, your service worker is told that, hey, I'm doing something, do not kill me. So it's a message sent to the browser. It's a way to tell the browser that, hey, I'm doing something. Unless this promise gets resolved, please do not kill the service worker. Now, in order to get the basic notification and to have the logic of if the user has closed the tab and show the notification, and if the user is on your website and your tab is active, let's show, instead of a push notification into the bar, let's show something inside the app itself. And a lot more to solve cross-browser things, to smooth out cross-browser problems. You can use one of the products as Firebase. So are two import scripts that will bring the core Firebase code and the Firebase messaging kind of code, and Firebase.initialize app. Now giving a message sender ID, you will tell that, hey, let's just initialize the event listeners inside the Firebase and get ready to receive all the push notifications. Now next is messaging.setBackgroundHandler. Now all of this code is specific only to Firebase. If you are not using Firebase, only add event listener and push should be sufficient for you. But if your the code itself gets complicated, this might be the thing that you want to do. Again, the thing that Firebase needs is that it returns the same self-registration.show notification, and you should be good to go. You can still receive the payload as you received it earlier, and you can generate the push notification here. But this set background message handler will only be fired if your user is not active on your website. If they are active on their if they are active on your website, the Firebase will send it to your index.html's listener and not to this background message handler. In order to take permission from the user, this is the smallest code possible. So when the service worker gets registered, it gets resolved. The promise itself gets resolved with a registration scope. And with this registration, there's an object as push manager. This push manager, you can call the function of subscribe. As soon as this function gets called, the UI of taking the permission from the user will be shown. So now the subscribe has, if you notice, this subscribe on line number 5 has an object of user visible only as true, which means at this point of time, if your web app receives a push notification, you have to show it to the user. You cannot choose to not show it at any point of time. You have to show it to the user. There is another spec of silent push notifications which you can use after some time to fetch a data from the API at regular intervals or maybe refresh your cache assets. But at this point of time, if your web app receives a push notification, you have to show that push notification to the user. If not, the browser itself will generate a push notification that says that this app has been updated in the background and will be shown to the user if you fail to generate a push notification. Now, there's also a case that you take the permission and then you change the service worker file itself. When you do this, the token that the GCM token that you get upon asking for the permission also gets changed. So for smoothing out all of these kind of cases, again comes Firebase. In case of Firebase, what you can do is you can just call messaging request permission, and that itself returns you the token of the user that you have to send it back to your server. This token is used to send GCM notifications to your users, the targeted GCM notifications. If I have 3 notifications from X, Y, and Z and I have to send a notification to only Y, I will take his token and generate a post call to GCM, or in this case, FCM, which is Firebase Cloud Messaging, and only a notification to Y user will be sent, or the Y user's device will be sent. This promise also gets rejected if the user presses cancel or deny in order to give you permission. If it does not want to give you permission, the promise will be rejected and you can do something accordingly at that point of time. Now, these were the three things. The service worker allows you to get to a very fine cache control. It also allows you to send push notifications. Manifest allows you to tell how does your website will look if it's added to home screen. But there are certain things which have not landed, so consider this as a sneak peek. Very soon, if somebody does an add to home screen, your progressive web app will not only land on the home screen, but also on the menu. At this point of time, in this menu, there are 3 progressive web apps added, and they look just exact as any other native app in this menu. I'll give maybe some swag to people who can point out which are the progressive web apps in this particular screen. Now, and if you long press these icons and drag them to the top, you will also see they will have their own storage and permissions in the Android settings menu itself. What more can we do with these kind of APIs? Let's say, so WebP is another image format which is really, really small in size. But instead of you adding the code into your markup and detecting whether or not the browser that the user has opened your website on supports WebP or not, you can just, now you are intercepting all the outgoing requests. In a very similar manner, you can intercept all your outgoing image requests, check if the browser has WebP support or not, If it does, you can alter the URL and get WebPs instead. So this is like one single code which fetches JPGs in older browsers and which fetches WebPs because if there's a net request interceptor in between known as service worker for the same code but on a newer browser. Background sync. Now this is a case where you don't have your user do not have network and they try to do some interaction, maybe retweet, maybe like a status, but your user do not have a network. At today's time, what probably most of us will do is we will go ahead and tell that, hey, something has gone wrong, please try again later, or the network's not there, please do it, please come back later. With this background sync event, what you can do is, if the network is not there, you can take the request inside the service worker, since you know that the network's not there, put it inside an index DB, and whenever network comes back, an event similar as fetch and push, an event known as sync, will be fired onto your service worker. At that point of time, you can take up all the requests or the queued requests from the index DB and replay them. So imagine an experience like this. I'll just go retweet as much as I want, go like the status as much as I want, and when the network comes back, your service worker auto plays all those requests. So user does not need to know that, okay, something has gone wrong, hey, my network's not there. Whenever the network will come back, your code will take care of it. Your code can now replay all those requests at a later point of time. Now some tools which help you to see whether or not you're doing a good job. A tool called Lighthouse as a Chrome extension is now available, and you can add that to your Chrome extension bar, and whenever you're done coding, you can just press it and see how good are you doing. So it generates some report like this. It checks if your progressive web app can load on offline or flaky connection. It checks how fast your first meaningful pain takes place. It also checks if the site is progressively enhanced or it's breaking because you have loaded service worker and other things where it's not supported. Okay, coming on to where exactly these progressive web apps can work at this point of time. So Chrome supports service workers, Chrome supports push notifications and background sync. Edge, the service worker implementation is under progress and behind a flag. So you can toggle that flag inside in Edge and start using service workers there. Firefox has already published the versions with service worker support. Opera supports it. UC Mini in their some versions where they use Blink already supports it. And Samsung Internet, the Samsung browser, default Samsung browser with the new Samsung phones also support service workers. Some examples that I have come across, and you should definitely check them out, are Flipkart.com, Housing.com, and there's the game paperplanes.world. Also, there's a directory of progressive web app as outweb.io. You can go to this directory and see all the amazing progressive web app that people are building. You should definitely go check these out, add these to your home screen, and see what the new age experience looks like. Okay, so that was all that I had. I'm open to any questions that you guys have.
Security concept looking like? How are cross-site scripting attacks or man-in-the-middle attacks being addressed?
Okay, so his question is, how does service worker currently deals with security stuff? Maybe man-in-the-middle, cross-site scripting. So cross-site scripting is something that we have been dealing for quite some time, and the addition of service worker does not really change into that particular perspective. But for the man-in-the-middle, so as I told you, service worker controls every outgoing traffic and incoming push notifications and a lot more, and it's very low level. So hence, service worker is only available on HTTPS. So it makes sure that what service worker that you have written only reaches your user. There's no man in the middle that can breach in and add some other code and take control of your page. So if the service worker is controlling, if a service worker is active, it is practically controlling your entire page, what's going out and what's coming in. So hence, HTTP is a very first and very basic requirement of a service worker. Yeah. Anyone else?
Hi.
Hi.
You mentioned different browser support. What about OS support?
Okay. So, yeah. The pretty much Chrome supports it on Android and all the desktop browsers. Firefox, same, Android and desktop. All of these have pretty much Android, Windows, and desktop support. Apple is currently looking onto the service worker spec and hasn't really come out with any official word, but it's in their 5-year plan that they've published. So they have a plan which goes out. So they call it a 5-year plan. So it's not necessarily that they will take 5 years. It's just the name of that particular document is a 5-year plan.
I had a question related to Angular, please. Does Angular support this like officially from?
Okay. Okay. So one point that I'd like to call is service worker itself does not bind to any particular UI library, UI framework, because this is something beyond your application logic. So it can sit on top of a jQuery, Angular, React, and whatever. But an Angular CLI, I guess, yeah, Angular CLI has an option to automatically build a service worker for you. Yeah. Sure.
Since the service worker is intercepting every individual request, have you any idea of how big the overhead that it imposes is?
Okay, so yes, we are intercepting every outgoing request, and the delta is definitely greater than 0. Hence, the best practice is you do an if check that the event itself has the request object. So event.request.url matches whatever URL you want to cache or intercept. If not, just let them fall back to network. So the best practice is to first check the URL if it's the one that you want to intercept. If it does, only then do whatever operations you want to do with it. So depending on what operations you do and what device is being operated upon, the particular delta varies on it. But it's not really high, or even like should not be in any amount of hundreds of ms. Should be below that. Yeah.
As you mentioned, best practices, and I see this is rather low level.
Yeah.
And I think the code can get a bit messy, right? So is there any design pattern or best practice in this sense not to make the code messy?
Cool. So his question is, the entire API is very low level, so the code can get messy. In order to avoid that, there are a couple of layers of abstraction and as frameworks, as SW Toolbox, that one I've shown, SW Precache, and please look forward to this IO. There's another abstraction that is coming on top of it, which also builds your wrappers for background sync as well. So they're there to help you and minimize your coding effort really low. Yeah. Okay. Yeah.
Is there anything preventing a malicious website having a service worker runs in the background, does a little bit, and then at a later point goes off and downloads something on you, does something when you're not aware of it because you've long
yeah.
since
So
left the website?
as I told, service worker itself is awakened only by a few kind of events. That is, if your page is making a request, or your page is getting a push notification, or your page has requested for a background sync and the network has gone off and comes back on. These are the only 3 events when a service worker gets activated. If none of these 3 things are happening, service worker will eventually, the browser will kill the service worker in a very small amount of time after the user closes the tab. So there is nothing malicious that you or any spammy developer can do in a service worker. Yeah. Cool. Looks like it. Sure. Thank you.